Hi friends, today in this video I will talk about what is the function of what is a feed system and what is the function of a feed system in an injection mold. So the agenda for today's video is to knows about what are the different parts in a feed system. Our question is actually what is a feed system? Why it is required in an injection mold? As we all know, in an injection molding machine, the material we are putting in hopper, then it is passing through the barrel, then heaters will be there, and but finally actually the material will come out from the injection molding machine through the nozzle. So the exit from the injection molding machine will happen with the nozzle. So when the material hot melt will come out through the nozzle, next it will enter the mold. A mold, it may be a two-plate mold, it may be a three-plate mold, or it may be a split mold. As in my earlier video, I talked about the different type of molds. But whatever the type of mold, but the material will come from the nozzle, and now it will enter the mold. So the job is the purpose of the melt actually which is coming from the nozzle, its job is actually its function is to fill the cavities. If it is a single cavity mode, then on that case it has to fill that single cavity. If it is a multi-cavity mode, it has to fill all the cavity at the same time. So that actually defects will not be there in the product. So the feed system is like actually in our own body. It is like actually we are putting our food in the mouth, then it is going through our throat and then next actually filling the belly. In the similar way, the melt is coming from the nozzle. Once the melt is coming out from the nozzle, then it has to enter the mold. The path through which, the path through which is the way through which the melt will move from the nozzle and it will go through that path. Finally, it will fill the cavity. So between the nozzle and the cavity, the melt has to flow through a path. That path, that path consists with certain things, and that path is called actually feed system in case of an injection mold. Now, what are the things that are actually in the feed system? So, which are the parts consist actually in the feed system? So, in a feed system of an injection mold consists with a sprue, a sprue. Next, it will be a runner. First is sprue, next is runner. In some situations, there will be subrunners. Subrunners will not be there actually in all the molds, but in certain situations where actually the number of cavities are more, for example, 16 cavities, 24 cavities, 48 cavities, then on that case actually you cannot fill all the cavities only by the help of runners. You need actually subrunners during the design. So, first is sprue. Once the melt will come out from the nozzle, it will enter the sprue. That is the sprue boost. That part is actually called sprue boost. That path through which it will enter through, that one is actually called sprue. Next is runner. Next is subrunner. Once actually it will come from the runner or subrunner, then the melt will enter the entrance of the cavity. The entrance of the cavity is called actually gate. Like in all our houses or wherever we have an office or in our university, there is a gate at the entrance. Similarly, in case of actually cavities, to before the melt will will enter the cavity, it will go through a gate. So that gate design is also very important. If the design of gate will not be proper, then again certain issues will be there. You won't get actually good product. Sometimes there will be rejection of the products because of the gate design is not good. So it will go through the gate Then finally actually it will enter the cavity. So what are the parts in the feed system? One is sprue, next one is runner, next one is subrunner in some situation, next one is gate, and finally it will enter the cavity. But in between actually there is different parts in between your sprue, runner, subrunner and gate. There is one more part that is called actually cold slug well. Cold slug well. So as we know actually well meaning is actually to store something. So the function of that cold slug well is to observe the unnecessary material actually. Always what the mold designers they used to do, they used to keep this cold slug just opposite to the sprue. So whatever the unnecessary material, that means the melt which actually become already cold while passing through this sprue itself, that type of material actually it will be stored in the cold slug well, because cold slug well means cold meaning is actually once it will become actually the temperature will become low, so that it won't flow, and slug meaning is actually this is waste material. So the well which actually store this waste material, that means the melt which become actually cold and it cannot flow, that is called actually cold slug. So the material through the feed system will pass through the sprue, runner, subrunner, then a cold slug will be there. As I told you, actually just opposite to the sprue, exactly opposite to the sprue, you have to make the arrangement for the cold slug. During machining of the mold itself, you have to do it. And there will be gate, and after the gate, actually the material will enter the cavities. So, when the melt will flow from the nozzle, first it will enter through the sprue. So, it is a sprue bush made from actually some steel material. So, it is of circular section, and at the circular section, at the center, there will be a hole. And generally, that hole will be a taper hole. So, through the taper hole, the melt actually will enter. So, the job of that sprue bush, that part name is sprue bush, and its job is actually to connect your nozzle side and the runner side. One end of the sprue bush will be connected with the nozzle, and the other end will be connected with the runner. So that part job is actually to make a connection between your nozzle. It will absorb the melt, hot melt with high velocity, which is coming out from the injection molding machine to absorb it, and it will go through and it will discharge towards the runner. So that is the function of the sprue. The next is actually runner. Runner will be actually different designs of runners are there, and a separate video will go for actually what are the different design of runner design, runs of sub runner if required in some cases. So that is generally a circular section. Through that actually the melt will go towards your cavity, because when you are designing a mold for multi cavity, in that case actually you need runner. If you are designing a mold with only single cavity mold, a single cavity mold does not require any type of runner sub runner. That means that the sprue itself actually will be treated as gate. That's why its name is actually called sprue gate. But I am talking about actually multi-cavity mode. In case of multi-cavity mode, you need runner. And in some multi-cavity mode, you need sub-runner. When the number of cavities are more than certain numbers, as I told you actually, in case of a 16 cavity mold also, you need sub-runner. 24 cavity, you need sub-runner. 96 and all mean definitely you need so many sub-runners through which actually the melt has to flow. So the runner or subrunner is a passage through which the melt will flow from the sprue, end of the sprue, and it will connect the entrance of your uh, cavity. the entrance of the cavity is actually generally called as a gate because there you have to make the arrangement of gate. So the runner or sub-runner job is to connect the one end will be connected with the sprue, the other end will be connected with the gate. So next one is actually gate, that is actually at the entrance of your each cavity. If I am talking about multi-cavity, so in each cavity at the entrance you will have a gate. There are different type of gates, like rectangular gate, submarine gate, fan gate. So many varieties are there. One class actually, one video I talk about actually what are the different type of gate designs. So the job of that gate is to connect your runner. One end it will be connect the runner, the other end it will connect your cavity. So the melt, once it will come out from the runner, it will go through that gate, then it will enter the cavity, and once it will go from the gate, then it will fill the cavity. Correct? So these are the different parts. These are the different parts in case of feed system. So in short, a gate system in an injection mold consists with number one is with a sprue, number two runner and sub runner, number three gate, and you need also a cold slug well. As I already told you, the job of that cold slug well is only to absorb, to store the unnecessary material, and during ejection again actually it has to be thrown out with your gate. A gate and that feed system, inside the feed system actually the material after once it will cool down, it will stay inside that feed system, and this will be unnecessary material. This one actually you have to separate. You have to go for a secondary operation to remove this unnecessary material. Or in some cases, for example, in case of three plate mold, in case of three plate mold, what will happen actually? There is no need of secondary operation. Directly actually during ejection itself actually when all the three parts will be separate together actually individually, that time actually this gate and all the feed system actually separated. So you don't need a secondary operation. Okay. So with this, I may stop. What are the different parts in case of feed system or injection mold? As I told, the feed system required actually, this is a path through which actually the molten material will come from the nozzle and it will fill the cavity. So the path through which it has to flow, that consists with actually many parts, like actually first with a sprue, then it is with a runner, next is sub runner, next is gate, and finally actually it will enter the cavity. And in between actually you need a cold slug well. So these are the different parts in case of feed system of an injection mold. So with this I stop, and I'll have few more videos where actually screw design, runner design, gate design, as well as cold slug well design. Thank you. Thank you all.